जी स्टूडेंट्स, तो आज हमारी अगली बात जो शुरू होगी वो आयोनाइजेशन एनर्जी के मतलब है। नेक्स्ट पीरियोडिक प्रॉपर्टी इज आयोनाइजेशन एनर्जी। तो फर्स्ट ऑफ ऑल we will define ionization energy. It is amount of energy required it is amount of energy required for what? Required to remove an electron, amount of energy required to remove an electron from outermost shell of an atom, from the outermost shell of an atom in its gaseous isolated state. Means that atom must be in its gaseous state. Isolated state means that should be an independent atom, that should be a separate atom. And now the electron that is going to be removed should be the valence electron, such electron on which the hold of a nucleus is least, and the amount of energy required to remove that most loosely bounded electron, that energy is called activation energy. For example, if we have sodium gaseous atom and we will remove its last valence electron, it will be converted into sodium gaseous ion by the loss of one electron. The energy required for this purpose is 494 kilojoule per mole, and this energy is called ionization energy. Another example we can discuss: magnesium gaseous atom into magnesium monopositive gaseous ion, and its valence electron is again removed. Energy required is 738 kilojoule per mole. And in the next case, if we remove an other electron from this magnesium monopositive ion to convert into magnesium dipositive gaseous ion, now energy required is 1450 kilojoule per mole. Now there arises a question, a short question. Why IE2 is greater than IE1? IE2 is greater than IE1. A short question. Higher ionization energies are always greater than first. If we remove third electron, we further requires more energy. Its third ionization energy will be 7344 kilojoule per mole. So you know the reason why second ionization energy is greater than first. In the last lecture, we discussed that when positive ion is formed, it is smaller in size than its parent atom. That magnesium positive is smaller in size. So more energy is required to remove the next incoming electron because the hold of nucleus on the remaining electron increases. So second ionization energy is greater than first ionization energy. So these are the examples and a related short question. Now we will move towards factors. Now we will move towards factors and trends. Now we will move towards factors and trends. First of all, we will analyze here the factors affecting ionization energy. The very first factor is atomic radii, atomic radius. And the secondary factor that affecting the ionization energy is nuclear charge. It is the number of shells. It is the shielding effect. We will also discuss effective nuclear charge. We will also discuss electronic configurations. Some of the factors directly affect ionization energy, and some of the factors basically affect atomic radii. Main factor for the variation of ionization energy is atomic radii actually. So first of all, we will discuss the variation of these factors and effect of these factors on ionization energy. Then we will conclude them in the form of factors. First factor is atomic radius. As you know that in the previous lecture we have studied, in moving from left to right, atomic radius decrease. In moving from left to right in a period, we have studied that atomic radius decrease. With the decrease of atomic radii, hold of nucleus on the remaining electron becomes stronger and the removal of electron becomes gradually difficult. When atomic radii decrease, removal of electron becomes difficult. So ultimately result is ionization energy required to remove electron is increased. More of the energy is required in each step to remove valence electron. So we can say ionization energy increases. Now in moving from top to bottom in a group, very opposite trend is observed. As you know that in the previous lecture we have studied that atomic radii increase in a group. So as the atomic radii increase, the hold of nucleus on valence electron decreases. Removal of electron gradually becomes easy. So ionization energy, amount of energy required to remove electron gradually becomes lower. Less of the energy is required in each step, and we can say that ionization energy decreased. We can say that ionization energy decreased. So this is the effect of atomic radii. And the next factor we are going to discuss is nuclear charge. Actually, this factor basically affects atomic radii. As you know that in moving from left to right, As you know that in moving from left to right, nuclear charge, number of protons actually increases. So this affect the atomic radii. Due to increase of nuclear charge, actually atomic radii decrease. And when atomic radii decrease, in the same line we have studied that ionization energy is increased. So if with increase of nuclear charge, ionization energy should increase because of decrease of atomic radii. So we can say that ionization energy increases in moving from left to right due to nuclear charge. The same effect can be observed in moving from top to bottom in a group. Nuclear charge also increases. Nuclear charge also increases in a group. Nuclear charge also increases in a group. So the same effect is observed due to increase of nuclear charge. Atomic radii should decrease, but you know that other factors are working there, and in moving from top to bottom in a group, atomic radii actually increases. Despite the increase of nuclear charge, atomic radii increases, and its result is ionization energy decrease. Actually, the nuclear charge is working to reduce the atomic size and increase the ionization energy. But in moving from top to bottom in a group due to other factors like number of shells and shielding effect, we are going to discuss here in the next line. We will discuss number of shells and shielding effect. As you know that in moving from left to right, number of shells remains constant, and due to this, shielding effect is also constant. So they have no effect on ionization energy in moving from left to right. So they have no effect on ionization energy. No effect on ionization energy, but only in the direction in moving from left to right. When we will discuss this factor from top to bottom in a group, you know that number of shells increase, and due to increased number of shells, shielding effect also increases, and due to this, the ultimate effect is on atomic radii. The ultimate effect is on atomic radii. So in moving from top to bottom in a group, atomic radii increase, as you have previously discussed there, atomic radii increase. The main reason for the increase of atomic radii in moving from top to bottom in a group is increase of number of shells and increase of shielding effect. And whenever there is an increase of atomic radii, the ionization energy is always decreased. So in moving from top to bottom in a group, effect of this factor is ionization energy decreased. So in the next line we are going to discuss effective nuclear charge. we are going to discuss effective nuclear charge. Actually, it is the net force. Effective nuclear charge is the net force after the cancellation effect of atomic radii and other factors, nuclear charge and other factors. And you know that you have studied that in left to right nuclear charge increases. Number of shells and shielding effect are constant. So the net effect is again the same as created by nuclear charge. So we can say that in moving from left to right, effective nuclear charge increases and it produces same effect as the nuclear charge has caused. It results in an increase of ionization energy. It results in an increase of ionization energy in moving from left to right. Now coming towards from top to bottom in a group, effective nuclear charge decreases as the nuclear charge increases, but due to number of shell increase and effective shielding effect increase, they work in the opposite direction of the nuclear charge, and the resultant is effective nuclear charge. Now these two factors are more dominant. So effective nuclear charge in moving from top to bottom in a group decrease, and this results in an decrease of ionization energy. Decrease of ionization energy. Now we are going to discuss the last factor, electronic configuration. Now we are going to discuss the last factor, electronic configuration. Electronic configuration actually have no effect on ionization energy in moving from top to bottom, but in moving from left to right, it causes a variation and abnormality only at 2 points. Like it reverts the trend between 2A and 3A. Ionization energy by law 3A should be higher, but actually ionization energy of 3A is lower than 2A. It should be 3A should be higher, but the electronic configuration, due to electronic configuration and electronic configuration of 2A, as you know that it has completely filled valence shell, and in group number 3A the general electronic configuration is ns2np1. So this configuration is more stable, and the stability causes is to have a higher ionization energy. It's against the trend, it reverts the trend. Now similar variation is observed in between, similar variation is observed in between group number 5A and 6A. By law, the ionization energy of 6A should be higher, but actually it is 5A which have higher ionization energy than 6A. Again, going to the reason that 5A have half filled valence subshell as compared to group 6. Now this again have a half filled stable subshell, which causes to have higher ionization energy than 5a. Electronic configuration do not affect ionization energy in moving from top to bottom in a group, because in a group electronic configuration remains same. So finally we are going to discuss the trends. In the light of above discussion in the form of factors, now we can conclude that in moving from left to right, ionization energy increases. Ionization energy increases because atomic radii caused it to increase due to increase of nuclear charge. These factors have no effect. Effective nuclear charge also works with the same direction as the nuclear charge increases. Electronic configuration causes variation at 2 points only. Generally, overall trend is increasing. At 2 points between group number 3A and 2A and 5A and 6A, trend is reverted, trend is changed, and we have discussed it. Now, in moving from top to bottom in a group, in the light of above discussion, as we know that atomic radii we discussed increase and causes a decrease of ionization energy. Nuclear charged tend to increase and tend to uh, increase ionization energy. What is it decreased due to these two dominant factors? Due to these two dominant factors, number of shell and shielding effect, and it results in an decrease of effective nuclear charge. Electronic configuration does not affect. So overall trend is ionization energy decrease in moving from top to bottom in a group. So that's all for today, and this is the overview of the today's lecture. It's ionization energy.